Today we are performing lab of Internet Protocol IP, which plays a key role in the Internet, and we know way to transfer packets with the help of IP address. So in this lab we will investigate IP protocol focusing on IP datagram. And before doing this lab you have some basic knowledge which is a prerequisite for this lab of IP. First phase of this lab is execution of trace route, as there are some instructions given here, and if you want to run the trace route you have to go to trace route and blink plotter. Let me show you the blink plotter of gaia.cs.umos.edu, which shows the latency and average, minimum, and current, and the name, the IP address or the host name, and it's the IP address, and it's the count, and this has a hop, like hop, maybe it's like a serial number, and this is the graph of that particular host name. And after completing this, do this following as told, as I already do. It told that capture start, and we are capturing from WIRESHARK, and here it showed the taking the advanced options and taking the packets. Okay, so if not we by not doing this advanced method, we take the WIRESHARK traces, and let me show you the WIRESHARK trace of IP. This is the WIRESHARK trace of IP. In this, all the IP packets were, and here ICMP means Internet Control Message Protocol. So by not doing this, all these phenomena, we're just downloading our trace file and checking what are the insights in the trace route. This is the first phase of our project, and second phase is a look at the captured trace. As we have the captured trace that we have downloaded from WireShark traces, it told and have some, as if you want to print that any packet, this you have to go on some click on packet and file and print, then you will get the total list of packet. Okay, and also you can select a selected packet, how many packets do you selected, like that, and what's the range. After that, in the second phase, it told to select the first echo request message sent by your computer and expand the internet protocol part, request path. Then we should go here, and where we did the at 8 packet we have request. So let me show you. IP address is 192.168.1.102. You can see here. And from this IP, they're asked questions. If you want to filter this, you can enter here ICMP. Then you will get the request and time to leave messages, which shows the statistics and information about the packets. After this, there are some questions like select and expand, as I already showed all the information to you. And what is the IP address? You know that this is the IP address 192.168, which is our source. And what is within the IP address? What is the value of upper layer? Let me show you the value of upper upper layer is uh, the value of upper layer is, let me show you. uh, Sorry, 1 second. This is the request. Ah, the value of upper layer is ICMP bracket of 1. How many bytes are in IP header and how many bytes are in payload? Explain how we determine. Let me show you. 20 bytes we have in header and 20 bytes we have in payload, and 64 bytes we have. The total length is 84. The header length is 20 and payload is 64. Let me show here. That the header total length is 84 and header length is 20. Total length equal to header plus payload. Then 20 plus 64. 64 plus payload, header is for 20. Right? And has this IP datagram fragmented? How you determine? This IP datagram is not fragmented. Its flag is not set. Then it's not fragmented. Let me show you. Its flag is 0. Flag offset is 0. So it's not set. If it's some value, then it's so that it has some fragmentation. And there are some other questions like which fields in the IP datagram always change from one datagram to another. The fields that are changed are identification field, TTL field, and header checksum field. And the next question is which fields stay constant? By leaving that fields, all fields will stay constant. And describe the pattern you see in this field of identification field. The part that we see in identification field is increased by 1. Let me show you it is how it is increased by 1. You can see identification is 13008. Then when I click on this, then identification field will be increased by 1. It is increasing by 1 at each time. See, 13009 and here 13008. It is increasing by number 1. And what is the value of identification and TTL field? We already seen what is the value here. Identification field, TTL field. And does this value remain unchanged? Does this value remain unchanged? The identification value is changed, but the TTL is unchanged. You can see TTL is 1, but identification has changed by 1. If you see here, TTL is changed. The time to live is also increased by 1. So we can tell that TTL is also changed. 1 second. Yeah, TTL is also changed. And the 10th question is find the first ICMP packet that request message was sent by computer to be 2000. So let me show you the packet which is of 2000. 1 second. Packets. Yeah, it's 56, but we need the 2000 length. So yeah, you can see the packet of 2000 as we attract that and print out the first fragment. For printing, as I already told you, just you need to go to file and print the packet. Print out the second fragment of what information. So as I already printed here, 12 is also like printing the second packet which is below of that, right? Which is below of that. What fields change in IP header between first and second segment? Let me tell you, the fields are total length, flags, more fragments, and flag offset are changed between the IP header first and second fragment. How many fragments were created from original datagram? Three fragments. There are three fragments created from original datagram. You can see like two IPv4 fragments, and before that, see how many uh, fragments were created. There are three fragments were created. Like there are three fragments were created, and what fields change in IP? As you already know, total fragments, more fragments, flags, and frame offset. These are the values changing that. So by these we are completed with our IP lab. Thank you.